Hey guys, Mr. T here. This is another video. This one is on 2D shapes. Hopefully it's all a bit of a revision and it's really like sort of early junior maths or even late primary school, but I might as well. I figured I would do a video just for the sake of completeness. So a 2D shape or two-dimensional shape is one that lays flat on a plane. We're initially going to deal with two types of 2D shapes, polygons and circles. So polygons. A polygon is a figure made up of line segments and points. So the line segments are called sides and the points are called vertices. I should have quoted that and underlined it and kept them the same. The sides must fully close the figure and the sides must not cross over each other, e.g. So we've got A, B, C, D here. You can see there's points and line segments, but the line segments do not close, so this is not a polygon. This next example, not a polygon. This next example here, it looks closed, but we have sides that cross over each other, so not a polygon. However, this last one, we have line segments, points, it's fully closed. Excuse the bad drawing. I'm drawing with plastic on plastic, so it's going to be a bit slippery, and no crossing over, so this is a polygon. Straight sides between points and no crossing over and fully closed, so that's what makes a polygon at its most basic. So polygons are named according to the number of their sides and vertices, so hopefully you all know that this is called a triangle. Why is that? 3 sides, 3 vertices. The next one has 4. It's called a quadrilateral. 4 sides, 4 vertices, or corners, you could even say. This is a pentagon. So after 4, it uses the Polygon naming system. Everything ends with a gon, and the prefix indicates the number of sides and angles. So 5 sides, 5 vertices. This is a hexagon, standing for 6. I'll just write verts. For 7, it is a heptagon. 7 sides, 7 verts. 8 is an octagon. Oh, I wrote 8. Octagon. 8 sides, 8 vertices. And then lastly, I'm going to stop here. Your book has more. 9 is non-gon. You could always look up these side prefixes online anyway, so it's not vastly important to remember them or memorize them, just understand where the system comes from. Now you might think these are kind of weird looking polygons. That's because they followed the rules of a polygon. They are polygons. What you're used to is regular polygons. Regular polygons are the polygons you are most familiar with. Regular polygons have sides that are the same length, and because of that they have the same angles between them. So this is strictly a quadrilateral. Why? Because it's got 4 sides and 4 corners, but these angles are all different. What you're used to, and I don't think this is perfectly a square because of the drawing of the app, but we'll pretend it is. These sides are all the same length, and because of that the angles are forced to be the same as well, and they'll be 90 degrees. That is a regular polygon, and that has a special name as well as square. I'll try to draw one as well. The pentagons that you're used to sort of look nicer. They don't look like a house shape, they're sort of like that, but they'd all be the same sides and the same angles. You are more regularly used to regular polygons where the sides and the angles are all the same. Just be wary that these are polygons too. They're just not regular ones because their angles and sides are slightly different. Next concept we have to go over is the concept of polygon diagonals. A diagonal of a polygon is any straight line segment joining two vertices across from each other. This is not a diagonal, that is a side, because they're not across from each other, they're right next to each other. However, this going across to that one there is a diagonal, because they are across from each other, but this is also a diagonal. Alright, anything where it has to go across from one vertex to another vertex is considered a diagonal. It's not just the lines from corners of, didn't even draw that properly, corners of, say, a square or a rectangle. Those aren't the only types of diagonals. Diagonals are from any vertex to a vertex across from it. So just remember that. Alright, the next type of shape that we need to deal with is circles. Hopefully this terminology is revision again. So circles are shapes that are not polygons. This is because they have a single curved side. They're closed, yes, but their sides are not straight line segments. Circles have several important properties, and we'll go over them here referring to this diagram. So firstly, as a mathematical definition, a circle is a shape formed around a central point. So we've got a center here, the shape of a circle around, and the sides are, the side is a single-sided, and this is the closest thing to a single-sided polygon you'll have. It's got one side continuous going all the way around. The side is a curve of infinite points all the way around. It's curved, so it has infinite points all the way around that are equal distance from the center. So if I look at the center and measure from the center to the edge there, it's going to be the same distance from the center to the edge here, all over to the infinite points around. They're all going to be the same distance. So that's basically what a circle is. Now a radius is the distance from the center to the edge of a circle. For example, this green arrow here, center to the edge, is a radius. The diameter is a line segment that passes through the center of a circle. So the center's here. So this white line we're talking about here, with the endpoints on opposite edges. So the end of the diameter is there, the other end is not there, so they're opposite sides. That is the diameter going across there. Both halves of the diameter are a radius, so you'll see this half of the diameter is from the center to the edge, so it's also a radius, but this is also a radius on the other side. So a property you should remember is that diameter is equal to 2 lots of the radius. And the opposite of that is a radius is half a diameter. A semicircle is a curved line around the edge of half a circle. So this red mark here around the edge of half of the circle is a semicircle, and is specifically the case because it's around half of the circle. An arc is a curved line around the edge of part of a circle here, and just understand that a semicircle is a special case of an arc because it's around half of a circle, whereas an arc is any part. This is an arc, this would be an arc all the way around here, except this side could be an arc, okay? And lastly, a sector is an area bounded by 2 radii and an arc. So this blue pizza shape here is a sector. Why is that? Because it's between 2 radii, and an arc. Alright, so hopefully that's some revision for you and some terminology that you may have to use and refer to, and we'll see you in the next video.